Hello guys, I'm going to talk about the binary search. It is one of the most effective searching algorithms and it's very useful. Let's start given a sorted array of integer numbers. This is our array. It consists of 10 numbers, and if we want to try to find out a number, a random number exists in that array or not, we can say it, right? For example, 67 is it exist in that array or not?
Yeah.
Yes, we can say that. What about 100?
No.
No. So we can say that easily, but the computers doesn't work like that. Okay? We need a logic to find out the desired number. So what can be used as a logical? Here is the simplest way. To find out the desired number, we can try to search from the starting point, the first element, right? Let's say we are trying to find out the x, okay? The simplest way, we can say, and we can compare from the first element, then scan whole the array. If you are lucky, you can find it at the first position. Otherwise, you will have an extensive search to find out, right? With the 10 numbers, that's easy. But what about if you have a million number? You don't want to do that. Neither computers. So here's our new approach to find out the desired number. Let's say we try to find out x. Instead of start from the first element, compare, we can start from the middle element of the array. So middle position, if you want to get the middle position, here is a simple mathematical operation. Let's say here left and here is right. To get the middle position, left plus right over 2 give us a middle position. It means here 5. Here is our middle position. Okay? So let's compare our desired number x with the middle position element. There can be only 3 cases here. First of it, case 1, x could be equal to our middle element, right? That means we found it. Search is done, okay? If we find the middle element, our desired element is that. That's all. What about case 2? X could be less than middle element. So now, if we have this case, we can discard the middle element because our array is already sorted. We can discard the middle element and hold the element after the middle element, right? Because we already know the x less than middle element. We don't have to look here, this side. You know, it's in that side. What about the last case? There's only one case left. X could be greater than middle element. So that means, similarly, you can discard the middle element and all the elements after the middle element. Sorry about that. All the elements before the middle element, right? Because we know x greater than middle element and our array has already sorted. So let's do that in a real example. Just say me a number here. Arzu, you want to say that?
67.
67. Let's try to find out 67. Which one is our middle element? Here, the 5th position, 39. 67 is greater than 49, right? So we have this case. So if our desired number greater than middle element, we can discard the middle element and also all the elements before the middle elements. Now what we have? We have reduced range to find out the desired element. So what's the main point here? Divide and conquer. That's all. If you have a big problem, you can divide it, then you can conquer it easily. Continue. Now our left positions has changed. Here is our new left value. Right is the same. What is our new middle element now? In here? 8, right? Because left value is 6 and right value is 10, over 2 is 7. Now we can compare the desired number with middle element, new middle element. Which one? 55. This condition is right, right? 67 is greater than 57. So the same operation. We can discard the 57, then we can discard all the elements before the 57. 55, sorry about that. So, we are going to do the same operation. Here is our new left, and here is right. Now, what is our new middle element?
No.
9. Here. What's our condition? 67, less than 9th element, which means 81. So, we can discard the middle element and all the elements after middle. Now what we have? Only we have the same for left and right value. So, it's obvious the middle element is 8 now, and we get the condition. So we find it. But here is the most important question. Is it going to be circulating forever? No, we don't have to do that. There is only 2 conditions to terminate our execution of program algorithms. First of all, we can find that our desired number, otherwise left side become a greater than the right side. So the last condition should be at most left could be equal to the right. Otherwise, the algorithms has over. That's all. You got it?
Yes.
Is there any question?
Thank you.
Okay. Thanks for listening.